Hi guys, I welcome everyone for the course Manipulated Robotics. It's a theory course. In this, we are going to see inverse kinematics today. So in inverse kinematics, you all know that with the help of Cartesian coordinates, if you are going to find out the joint coordinates, means then that is called as inverse kinematics. So let's see that. So today's topic is inverse kinematics. So kinematics is study of motion. So let's say a simple robot. So this is 2-hour manipulator. So this is 1 hour, this is how, so it is 2-hour manipulator. And then it makes an angle theta 1, and then this makes an angle theta 2. And then here comes your end effector, and then this coordinates are x1, y. So if your theta 1 and theta 2 is known to you, and if you supply that angle to a manipulator, automatically that gripper will be positioned at this point x and y. That is theta 1 and theta 2 is supplied. Okay, with the help of this, you will be able to find x, y. So this is called as forward kinematics. Kinematics means it's motion. So kinematics will say about the motion, study of motion. So when you give these angles, automatically your Cartesian coordinates or XY coordinates are known to you. So that is called as forward kinematics. So inverse kinematics is reverse. That is, if you give XY coordinates, XYZ coordinates, then the inverse kinematics formulation will help you to find the joint coordinates. Joint coordinates are theta or prismatic value. Okay. So let's say like the pictorially we can represent like this. So here your joint space. Joint space means this things. Okay, joint space. And then this is Cartesian space, which means end effector space. So there are two space. So if you move from joint to Cartesian means forward kinematics. If you move from Cartesian to joint means that is inverse kinematics. Okay. So this is the basic about forward kinematics and inverse kinematics. So in inverse kinematics, your xy values or xyz values are known to you. With the help of this, you should be able to find what is your theta or what is your prismatic value. So this is called as inverse kinematics. So this inverse kinematics method will give you a formula to find out the values for theta or d. Okay. So let's analyze inverse kinematics for 2-hour manipulator. Okay. So let's take 2-hour manipulator. So there are, two methods. One is geometric method. Another one is algebraic method. And we have numerical methods as well. Okay, so let's see geometric and algebraic method in this class. Okay, so we all know that if you want to find inverse kinematics, first you should know forward kinematics for 2-hour manipulator. So this we have discussed already that in the class, that is how to derive forward kinematics for the given manipulator. Okay, so you have to apply DH formulation to get the forward kinematics. So once you get the forward kinematics, then you have to derive the inverse kinematics. So the flow is first you have to configure the robot. Configuration. Configuration means you have only two joints in serial manipulator, revolute or prismatic. How we are going to arrange this? Either are you going to arrange RPP or PRP or RRP or RRR or PPR like that. Okay. So first you have to give the configuration. Once you give the configuration, you have to assign access for all the configuration. Then after that, you have to give DH table using DH formulation. Then you have to give DH matrix. Okay. Then you have to find OM matrix. Okay. Then you have to find out IK, inverse kinematics. So from this, we'll be able to find out the formulas for theta or B. This is the workflow. Okay. So in this, we are going to follow this algebraic method. So we know that the forward kinematics for 2-hour manipulator is, since it is a 2 DOF, so second joint with respect to the reference frame is equivalent to C12. C12 means C12 means cos of theta 1 plus theta 2. Okay. So C12 minus S12, then 0, L1 C1 plus L2 C12. Then S12 C12 0, L1 S1 plus L2 S12. Then V0 0 1 0 0 0 0 1. Okay. So this matrix is derived from the configuration, assigning axis, DH table, DH matrix, and finally OM matrix. So now we have got the OM matrix. So from this, we are going to derive the inverse kinematics. Okay. So let's see that. So in this, as per inverse kinematics formulation, your xy is known to you. So in this matrix, this is x, this is y, and then this is z. Since it is a planar manipulator, you will not have a z value. So we assume that we know the value xy. So we are going to take this value. Okay. So what is our x? X equal to L1 C1 plus L2 C12. Y equal to L1 S1 plus L2 S12. Okay. So now what we are going to do is we are going to square it, and I'm going to add it. So let me square this. X means the whole thing, whole square. Okay. So it is L1 square C1 square plus L2 square C12 square plus 2L1 L2 and the C1 C12. Okay. Plus next one, this term. So L1 square S1 square plus L2 square S12 square plus 2L1 L2 S1 S12. So let's combine this L1 square and then L1 S1 square, which is L1 square, because C1 square plus S1 square is 1. So let's take L2 square and this term. So from this, C12 square plus S12 square is 1. So L2 square. Okay. Then we have these terms left out. So in that, let me take the common terms, 2L1 L2. In the bracket, it is C1 C12 plus S1 S12. Okay. So this remains the same. So here we have to do something. So C12 means cos of theta 1 plus theta 2. The formula is C1 C2 minus S1 S2. And then S1, this is the trigonometric identities. So C1 S2 plus S1 C2. Okay, let's substitute here. So C1, in the place of C12, you have to write C1 C2 minus S1 S2. Okay, plus S1, in the place of S12, you have to write C1 S2 plus S1 C2. Okay, so here also, let's, this will be the same. So here multiply this C1 square C2 minus C1 S1 S2. Then here when you multiply this S1 C1 S2, then S1 square C2. Okay. So this we can cancel. In this, the common term is, S1 square, S1 square C2, there's no square. Okay, so C1 square and S1 square is 1, and the common term is C2. So this entire term simplification is C2. So now L1 square plus L2 square plus 2L1 L2 C2. So this is your x square plus y square. From this I can get the C2. So what? So I can say theta 2 equal to cos inverse of x square plus y square minus L1 square minus L2 square divided by 2L1 L2. Okay, so this is our theta 2. So using inverse kinematics formulation, we found the formula for theta 2. So theta 2 is cos inverse of x square plus y square minus L1 square, link length, minus L2 square divided by 2 into L1 into L2. So this is your theta 2. So now we are going to find out your theta 1. Okay. So for that, let's take, so now we are going to find theta 1. So let's take the formula, the x value, L1 C1 plus L2 C12. Then y equal to L1 S1 plus L2 S12. So here we are going to do a simple simplification. So let me expand this L1 C1 plus L2, and then C12 already we know that C1 C2 minus S1 S2. So C1 C2 minus S1 S2. Okay. So let me expand this L1 C1 plus L2 C1 C2 minus L2 S1 S2. Okay. So in this, I'm going to split like this. So here C1, I'm going to take the C1 out common. So L1 plus L2 C2. Okay. So this is my C1. And similarly, minus S1 L2 S2. Okay. Similarly, we'll simplify this. So L1 S1 plus L2 S12 is S1 C2 plus C1 S2. Okay, so let's expand this L1 S1 plus L2 S1 C2 plus L2 L1 S2. Okay, now I'm going to split this as, so this is our Y. So now I'm going to rearrange like this, like so here also C1 the similar way. So C1 here is so here this is C1. Okay, C1 is L2 S2. And then in this, I'm going to take the S1 term outside. So S1 term, if you take outside means it is L1 plus L2 C2. Okay. So now we have arranged this term. So this is my X and then this is my Y. Okay. So now what I'm going to do is I'm going to do one simple thing. That is, I'm going to multiply C1X plus S1Y. Okay, so that we'll be able to get theta 1. So this is algebraic method. So C1, okay, what is your X? So this is your X. So directly multiply this by C1. So C1 square L1 plus L2 C2. Okay, then here also you have to multiply by this C1. So C1 S1 L2 S2. Okay, so this we have done. So next one is we have to multiply S1Y. Okay. So now we have done C1X, we have done, then S1Y. So S1 and Y is here. So S1 means, so S1, C1, L2, S2. And then when we multiply this, it becomes S1 square, L1 plus L2, C2. Okay. So this simplification is, so this one will be cancelled. Then the common terms are L1 plus L2, and then C1 square plus S1 square is 1. Okay, so this is one simplification. Next one is C1Y minus S1X. Okay, so let's multiply. C1 should be multiplied by Y term. So when you multiply this, you will get C1 square L2 S2. Okay, plus C1 S1 L1 plus L2 C2. Okay. Then minus S1X, minus S1X. So minus S1 C1, L1 plus L2 C2. Okay. Then the same minus, so minus minus plus S1 square, S1 square, L2 S2. Okay, so here you can cancel this and this. Then from the remaining terms, it is L2 S2, C1 square plus S1 square is 1. So from this, we are going to derive the formula. Okay. So I think, remember this, I'm going to recall the next slide. So now what we have done is we have done C1X plus S1Y, and then we are going to take the ratio. So C1Y minus S1X. Okay. For this, the answer we got is L1 plus L2 C2 divided by L2 S2. Okay, let's assume this to AB and we can cross multiply this. Okay, when you cross multiply this, it becomes, so this one is multiplied by this, so it becomes, so here B into A. So B C1X plus B S1Y. Then here A C1Y minus A S1X. Okay. So in this, I'm going to collect S1 one side. So S1 one side means, so here B S1Y. So bring that S1. So plus A S1X. Okay. So here A C1Y and then bring this term here B C1X. Okay. So take S1 because I need to have theta 1. So that's why take S1 outside. So you will have By plus Ax. Okay, then here's take C1 outside. So you have Ay minus Bx. Okay. So S1 minus, sorry, C1 equal to theta 1 is equivalent to Ay minus Bx divided by By plus Ax. Okay. So we can have like theta 1 equal to, so what is A? A is L1, L1 plus L2 C2. Okay, into Y minus B is L2, B is L2 S2 into X. Okay, divided by your B is L2 S2 Y and your A is L1 plus L2 C2 into X. That's all. So this is your theta 1. The previous slide we have seen what is theta 2. So in this way, we'll be able to find the joint coordinates. So theta 1 and theta 2, we found it. We have using some formula with the help of x and y. So x and y is used. I mean, x, y coordinates are applied over here. Over here means in inverse kinematics to find out the formula for theta 1 and theta 2 using algebraic method. Okay, thanks for watching.